We'll now move on to our second derivative test, a way to check even easier if we have maximums or minimums. We're going to start by having our critical points, so we need x0 to be a critical point, and we need the second derivative to exist at this point in the first place. And if our second derivative at this point is less than 0, then we have a maximum. And if our second derivative is positive at this point, then we have a minimum. And that's it. And once again, we can do these if we remember concavity. A negative second derivative means we're concave down, which looks like a maximum. And a positive second derivative means we're concave up, so it looks like a minimum. Let's do some examples. Here I have my function, x cubed plus 5x squared plus 4x plus 2. We start with the derivative. That's 3x squared. Plus 10x plus 4. This is not going to factor nicely, so we're going to need to use our quadratic formula. We have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And once we simplify this, we get negative 10 plus or minus the square root of 89 over 6. So this may not be the best answers, but we can work with it, and I purposely wanted to do one like this, because most of the time these are what our answers look like. The next thing we need to know is the second derivative. Well, that would give us 6x plus 10. And then we want to know if these numbers are going to be positive or negative. Well, that's actually not too hard to figure out. If I look at this first one, negative 10 minus the square root of 89 over 6. When I multiply by 6, it's going to cancel the denominators. And then when I add 10, this negative 10 is going to cancel. I just get negative square root of 89. So it's going to be negative, which is concave down. Same thing here. When I multiply by 6, the denominators cancel, and when I add 10, the negative 10s cancel. So I actually get that the second derivative value is positive 89, which means I'm going to look like this. So this one's a maximum, and this one is a minimum. Let's look at f of x equal to negative x to the fourth. Well, my derivative would be negative 4x cubed. And if I set that equal to 0, I'm just going to get that x is 0. So I only have one critical value here. Well, when I find the second derivative, I get negative 12x squared. And the second derivative of this point is equal to 0. So what happens? My second derivative test tells me what happens when this number is positive and when it's negative, but not when it's equal to 0. Well, negative x to the fourth looks something like this. Kind of missed the graph here, but it is a maximum. Does that mean that every time the second derivative is equal to 0, we get a maximum? Well, let's look at another example. F of x equal to x to the sixth. If I take the first derivative, I get 6x to the fifth. So x is equal to 0 whenever this is equal to 0. My second derivative is then 30x to the fourth. And the second derivative at 0 is once again 0. However, this time, my graph looks more like this. This time, it's a minimum. So whenever my second derivative is equal to 0, I'm going to have to use different methods to figure this out because as I can see, it could be a maximum or a minimum. Let's look at one more. What about x cubed? Well, my first derivative is 3x squared. We know that my critical point, this is equal to 0 when x is 0. My second derivative is then 6x. So my second derivative is 0 once again. But this time, it looks like this. It's actually neither a maximum or a minimum. So essentially, if you do get that your second derivative is 0, you're going to have to use different methods to figure this out.